Dr. Ishikawa, and today we're going to measure tree height with a clinometer. So this is our clinometer, and we have a clinometer. So clinometers use angles to use an angle and a distance away from the tree and trigonometry to determine the tree's height. And so we'll go over that in class, but for now I'll show you how we use our clinometers, because our clinometers have already done the trigonometry for you, and so they will read the height directly if you are either 15 meters away and you read the right side of the scale, or if you're 20 meters away and you read the left side of the scale. And so if you're 15 or 20 meters away, it will just tell you right on there what the height of the tree is. And each time that we measure a tree, we're going to get the height to the top, and what that really tells you is it tells you how far above my eye height the tree is. So that's not really how tall the tree is, it's just how much taller the tree is than my eyes. So to get the whole tree's height, we also have to figure out how tall it is from my eyes to the base of the tree. And so we take a reading at the base of the tree. And what we'll do is we'll subtract one from the other. We'll subtract the base of the tree from the top of the tree each time that we do a reading. Okay, so I'll show you for this one. For this one, we measured from the tree. Out to 15 meters. So I'm 15 meters away from this tree. So that means I'm going to read on the right-hand side of the clinometer. And one of the things you want to check is that when you're reading the clinometer, that it's not the angle of the clinometer doesn't go above 60. So it should be somewhere around 30-ish. So I'll try and see when I look at the top of the tree. I look at the top of the tree with one eye, and I look in the clinometer with the other eye, and there's a black line that I want to line up with the top of the tree. And the black line also lines up with the scale on the clinometer. And I said we're 15, right? So 15 meters away, I'm reading 9.25 for the top, and then I'm reading negative 1.5 for the bottom. So I had 9.25 on the top and a negative 1.5 on the bottom. So I would subtract the negative 1.5, which means I would add the negative 1.5. So I'd do 9.25 plus 1 would be 10.25 plus, so it'd be 10.25 plus another 0.5 would be 10.75. Okay, so 10.75. And let's just check that. I like to check and do my imagine tree falling check. So 10.75 is about right here. So I'll imagine the tree falling on me. And yeah, that looks about right, that the tree would fall right around here. So I know I'm in the ballpark. So I will give you an example on the next one, show you what it looks like if you're way off, if you forget to do something. All right, that's it for this tree. We'll go on to the small tree. Okay, so here is an example of a little tree where you don't really need to go back a whole 10 or 15 feet, and you could, but if you go back too far, it's not as precise, and so sometimes it's better if you can just do it closer. And so for this one, we measured 7.5 meters, so I'm 7.5 meters away from the tree, and I can do my measurement right here. So I'll measure the top, and since it's 7.5, I'm gonna read the right-hand side of the clinometer this time. And let's see, so on the right-hand side of the clinometer, the line, and you can see that I'm not craning my head back. It's easy for me to see the top, and I'm reading 8.5. And then at the base of the tree, I'm reading 3.5. So, negative 3.5. So it was 8.5 at the top, negative 3.5 at the bottom. So now I'm going to actually do the math right this time. So 8.5 minus negative 3.5 will be the same thing as 8.5 plus 3.5, so 12. So it's 12. And if we think about it, so I'll do my little test. So I'll come back 12 meters. I gotta go back a little farther. Let's see. Come back to 12 meters. And imagine the tree falling. So imagine the tree falls on the tape. I say, whoa, that does not look right. So, and they say, oh, whoops, I forgot. I was half the distance, so I need to do half the height. So it's actually 6. So it's 12 divided by 2, because we were half as far, so we divide it in half. So if we imagine 6, yeah, I can imagine that it would probably fall right around here. So that's roughly right. All right. Hi, this is Dr. Ishikawa. Here is our last tree. So this is what happens if you have a large tree. There's two reasons you don't want to take your reading too close. One reason is that you may not really be able to see the top of the tree. So sometimes I'll have students think they can see the top of the tree, but then when we back up, they see that, oh, there was another top of the tree behind that they just couldn't see. So you got to make sure you're back far enough that you really see the top of the tree. The other thing is that the clinometer loses accuracy as you start pointing it above 60 degrees. So if you look at me trying to do the top of the tree here, I'm pushing 60, so, or maybe over it. So, and I'm craning my head, so you can see, you don't want to have to do that. That's not good for your neck, and it's not going to be a good measurement. So what we're going to do is I'm going to run back here. So now I'm back at 30 instead of 15 meters. You didn't want to run after me like cops. The cameraman running. So now I'm 30 meters away. So that's a multiple of 15. So I'm going to use the 15 side, but since we're 30 meters, or double the distance, we're going to double the height once we read it. So I will read the top of the tree on the right-hand side of the clinometer, and I'm getting 9.5 again. Interesting. So I keep getting the same one. All right, and on the bottom, I'm getting negative 0.75. So I got negative 0.75 on the bottom and 9.5 on the top. So I'm going to do 9.5 minus the negative, so it's 9.5 plus 0.75, so that's going to be 10.25. Okay, so that's 10.25. I got it this time. And so, but let's do, if we did our, well, you can just imagine if we did our, is the tree gonna fall on you test at 10.25, it would like crush me, so that would not be tall enough. So, but let's try is the tree going to fall on me test at 20. So if we go to, it was 10.75. So if we double that, that's 20 plus 1.5, 21.5. So if we go out to, oh, it's over here, 21.5. Yeah, that seems about right, that the tree would fall and it would just crush me with the tip of it. So, but if we go up to, so that seems about right, that it's about 21.5, but let's just go to 10.75. Oh yeah, definitely. This is definitely not long enough. We definitely know that we needed to double that. So, yeah. All right, so this is the last tree in our video, and we'll have another video of me on the computer showing you how to do the calculations, to review the calculations. All right. So that'd be 1 would be 7.75? No. What would it have? Had 9.2.